The 1960s were a time of great change and upheaval. The Cold War divided the world into two camps, the capitalist West and the communist East. In this charged atmosphere, a new competition emerged, the space race. The Soviet Union launched Sputnik, first artificial satellite, in 1957. This event stunned the United States and ignited a fierce rivalry. The space race was a battle for prestige and ideological dominance. Both superpowers poured vast resources into their space programs. The goal was clear: land a man on the moon and return him safely to Earth. The challenge of landing on the moon was immense. It demanded the collective efforts of hundreds of thousands of scientists, engineers, and technicians. NASA, the newly formed space agency, embarked on a crash program to develop the necessary hardware and software. Every component, from the massive Saturn V rocket to the delicate lunar module, had to be designed and built from scratch. The Apollo program, as it was known, was the most ambitious and complex technological undertaking in human history. It required the development of entirely new technologies, such as powerful rocket engines, heat shields capable of withstanding the searing temperatures of atmospheric re-entry, and lightweight materials for spacecraft construction. The stakes were incredibly high, as any failure could have disastrous consequences. To prepare for the challenges of lunar landing, NASA conducted a series of increasingly complex missions. The Mercury program sent the first Americans into space, while the Gemini program developed the techniques of rendezvous and docking in orbit, essential for a lunar mission. Each mission brought valuable experience and paved the way for the ultimate goal of landing on the moon. Spaceflight is an inherently dangerous endeavor, and the Apollo astronauts faced numerous risks. One of the most significant dangers was the possibility of a rocket failure during launch or ascent. The Saturn V, while a marvel of engineering, carried millions of pounds of highly flammable fuel, and any malfunction could have resulted in a catastrophic explosion. Once in space, the astronauts were exposed to the hazards of the space environment, including extreme temperatures, radiation, and micrometeoroids. The vacuum of space also posed unique challenges, such as the need for specialized spacesuits to provide pressure and oxygen. Moreover, the long duration of the mission, lasting over a week, put a strain on both the physical and mental well-being of the crew. Despite the inherent risks, the Apollo astronauts were highly trained and prepared for the challenges of spaceflight. They underwent rigorous physical and mental conditioning, spending countless hours in simulators and practicing emergency procedures. Their courage and dedication were an inspiration to millions around the world. On July 16, 1969, the world watched as Apollo 11 launched from Cape Kennedy, Florida. The Saturn V rocket, towering symbol of human ingenuity, roared to life, carrying astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins on their historic journey to the moon. The launch marked the culmination of years of intense effort and the realization of a dream shared by many. After a 3-day journey, the lunar module, nicknamed Eagle, separated from the command module and began its descent to the lunar surface. With Armstrong at the controls, the Eagle navigated the treacherous lunar terrain, avoiding craters and boulders. As the world held its breath, Armstrong announced, "Houston, Tranquility Base here. Eagle has landed." A few hours later, Armstrong became the first human to set foot on the moon, uttering the now iconic words, "It's one small step for man, one giant leap for mankind." Aldrin soon joined him on the surface, and together they spent the next 2 hours exploring their surroundings, planting the American flag, collecting lunar samples. While the world marveled at the televised images of the moonwalk, there were countless behind-the-scenes moments that captured the human side of the mission. One such anecdote involves a broken switch on the lunar module's ascent engine. With our lives depending on a successful liftoff from the moon, I improvised a solution using a felt-tip pen. Activate the switch. Another lesser-known fact is that the astronauts carried a small silicon disc etched with goodwill messages from leaders of 73 countries. This disc, left on the moon as a symbol of unity, represents the hope that space exploration would transcend political divisions and inspire collaboration among nations. These stories, often overlooked in the grand narrative of the mission, highlight the ingenuity and resourcefulness of the astronauts and the team back on Earth. They remind us that even in the face of immense pressure pressure and uncertainty, human ingenuity can prevail. The Apollo 11 mission was a testament to human ingenuity and technological advancement. The Saturn V rocket, the most powerful ever built, stood over 363 feet tall. Its 5 F-1 engines produced a deafening roar felt for miles. The Apollo spacecraft consisted of 3 main modules: Command, Service, and Lunar. The Command module, where astronauts lived, had a heat shield for re-entry. The Service module housed propulsion, fuel cells, and essential equipment. The Lunar module, designed for moon landing, was a triumph of lightweight engineering. Apollo's technological innovations extended beyond the hardware itself. The mission relied on sophisticated communication systems and a global network of tracking stations. As the Lunar module approached the lunar surface, Armstrong and Aldrin faced a number of challenges. The original landing site, a smooth plain selected from orbital photographs, turned out to be littered with boulders. With fuel running low, Armstrong had to take manual control of the lunar module and search for a safe landing spot. Adding to the tension, the lunar module's computer began flashing alarm codes, indicating an overload. Fortunately, Mission Control in Houston quickly determined that the alarms were not critical and gave the go-ahead for landing. With only seconds of fuel remaining, Armstrong guided the Eagle to a gentle touchdown in the Sea of Tranquility. The successful landing, against all odds, was a testament to our piloting skills and the cool-headedness of the Mission Control team. It marked a pivotal moment in human history, proving that we could indeed reach out and touch another celestial body. Once on the lunar surface, Armstrong and Aldrin conducted a series of experiments and collected lunar samples. They deployed a solar wind experiment, a seismometer to measure moonquakes, and a laser reflector that would allow scientists to measure the distance to the moon with great accuracy. The astronauts also collected over 47 pounds of lunar rocks and soil, carefully documenting their findings. These samples, returned to Earth for analysis, provided invaluable insights into the composition and history of the moon. They revealed that the moon was once volcanically active and that it shared a common origin with Earth, formed from the debris of a giant impact early in the solar system's history. The lunar surface operations, though brief, significantly advanced our understanding of the moon and its place in the solar system. The data and samples collected during the Apollo missions continue to be studied today, providing new insights into the evolution of our celestial neighbor. After spending 21 hours on the lunar surface, it was time for Armstrong and Aldrin to rejoin Collins in lunar orbit and begin their journey back to Earth. The ascent from the moon was a tense moment, as the lunar module's ascent stage had to ignite flawlessly to achieve lunar orbit and rendezvous with the command module. Once docked, the astronauts transferred the lunar samples and other valuable cargo to the command module. The lunar module, its job complete, was jettisoned into lunar orbit, where it eventually crashed back onto the moon's surface. Command module then fired its engine, breaking free from lunar orbit and setting course for Earth. The return journey was a time for reflection and celebration. The astronauts had achieved the impossible, landing on the moon and returning safely to Earth. As they splashed down in the Pacific Ocean on July 24, 1969, they were hailed as heroes, their names forever etched in the annals of history. The Apollo 11 mission was a defining moment for humanity. It demonstrated the power of human ingenuity and the importance of international cooperation. The images of the astronauts walking on the moon inspired generations to dream big. The mission had a profound impact on our understanding of our place in the universe. Seeing Earth from the moon gave rise to a new awareness of our planet's fragility. The legacy of Apollo 11 extends far beyond its scientific achievements. It ignited a passion for space exploration that continues to this day. The mission was a testament to what humanity can achieve together. It remains a symbol of hope and inspiration for people all over the world. The Apollo program, though officially ending in 1972, left an enduring legacy. It spawned countless technological spin-offs, from freeze-dried food to scratch-resistant lenses, benefiting society in numerous ways. The program also fostered a spirit of innovation and collaboration that permeated many fields, from medicine to material science. Moreover, the Apollo mission sparked a renewed interest in science education and inspired generations of students to pursue careers in STEM fields. The dream of space exploration became a powerful motivator, encouraging young people to study math, science, and engineering. Today, as we stand on the cusp of a new era of space exploration, lessons learned from Apollo remain as relevant as ever. The spirit of innovation, collaboration, and perseverance embodied by the Apollo program continues to guide our efforts to explore the cosmos and unravel the mysteries of the universe. As we venture further into the solar system and beyond, we carry with us the legacy of Apollo, a testament to the boundless potential of the human spirit.